Learned about the sine, cosine, and tangent ratios of a right triangle. In this class, we take that a bit further and we consider the sine, cosine, and tangent to be functions of the angle. And what I'd hope that you'd gather from that verbiage is that we're eventually going to be graphing the sine, cosine, and tangent functions in the coordinate plane. But for right now, we're just looking at right triangle trigonometry. So you see the definitions on your screen. And what I'd like you to notice is that the cosecant is the reciprocal of the sine. Secant is the reciprocal of the cosine. And cotangent is the reciprocal of tangent. So they are appropriately named the reciprocal functions. You see that we are simply being asked what are the sine, cosine, and tangent ratios for angle P. Okay, so find where angle P is. We are setting up the sine of P, the cosine of P, and the tangent of P. This problem is just using the strict definitions of sine, cosine, and tangent. We're not doing anything with it yet. Okay, so the definition of sine is side opposite over hypotenuse. So looking at angle P, what is the side opposite angle P? The 15. So 15 over, what is the length of the hypotenuse? 17. There it is. There's the sine of P. Cosine of P is defined as the side adjacent to angle P. And the struggle that frequently arises at this point is that some students will say, but Mrs. Clouse, there's two sides that are adjacent to angle P, and you're right. However, I like to think of the hypotenuse as like a VIP, and he does not want to be confused with Mr. Adjacent, so don't you dare confuse him with just, adjacent, because the hypotenuse is always the hypotenuse. The adjacent depends on what angle you're talking about. Okay, so what is the side adjacent to angle P that isn't the hypotenuse? The 8. And it is over, that 17 is still my hypotenuse. And then finally, the tangent of P is what? What over what? The 15 over 8. We have already found the sine, cosine, and tangent ratios for angle P. When we are asked what are the cosecant, secant, and cotangent ratios, they're just the reciprocals of them. So the cosecant of P is 17 over 15. The secant of P is 17 over 8. And the cotangent of P is 8 over 15. In this example, we're asked to use one trig ratio to find the others. And the way that you do that is you consider a right triangle in which that ratio could exist. So here's what I mean by that. If I have a right triangle, and my theta angle is here, and the tangent of theta is 1/2, then that means that in the simplest triangle I can think of that ratio would be true. The opposite side would be 1, and the adjacent side would be 2. Well, if I'm asked for the remaining 5 trigonometric functions, I need to find the hypotenuse. Way back in geometry, you learned Pythagorean's theorem, a squared plus b squared equals c squared. So that's what we use here. So if I let's label it h for hypotenuse. So 1 squared plus 2 squared equals h squared. So that means 5 equals h squared, and h will be radical 5. So that means that the sine of theta will be 1 over radical 5. Ooh, we can't leave it like that. So we simplify it. We rationalize the denominator. And we get radical 5 over 5. The cosine of theta is 2 over radical 5. And once again, can't leave it like that. We rationalize the denominator, and we get 2 radical 5 over 5. They gave us the tangent, and then the other 3 ratios are just the reciprocals of the first 3. So cosecant of theta, I'm going to look at the ratio I started with for the sine of theta, which was this, and I'm going to take the reciprocal of that, because I don't know about you, but if I'm looking at this ratio instead and flipping it, I don't really want to rationalize a denominator twice if I don't have to. Take the reciprocal of this one. So it's just radical 5. And then the secant of theta is the reciprocal of the cosine. So that's radical 5 over 2. And then the cotangent, that's the reciprocal of the ratio they gave me, which is just 2. Here we have the trig ratios, all 6, for the 3 important special angles. And I kind of talked to you about this in the special right triangles video, that you are going to be expected to memorize these trig ratios, these values for 30 and 60 and 45. And in example 3, we're using the definition of the trig ratios in order to solve for x. So in part A of this example, I look at the 53-degree angle, I look at the 15 that is opposite it, I notice that the x that I'm solving for is the hypotenuse, and I know that the definition of sine is opposite over hypotenuse. So that allows me to conclude I'm going to set up my equation as sine of 53 equal to 15 over x. And one of the things that you want to be mindful of is, think of this sine 53 as being over 1. Way back in Algebra 1, one of the properties that you learned of proportions, which is what I'm looking at right now, is that you're allowed to interchange things across the diagonal, and it's equivalent. So I'm going to switch the x and the sine 53 and get that x equals 15 divided by the sine of 53, which in my calculator is 18.8. In part B, I look at the 21-degree angle. I notice that the 9 is opposite it. I know that the x is the leg adjacent to it. So opposite and adjacent means I'm going to use the tangent function. So tangent of 21 equals 9 over x. And once again, when I have x in the denominator, it makes it a lot easier for me to solve if I just switch things across the diagonal and get that x equals 9 divided by the tangent of 21. So that's 23.4. Pause your video to work through the your turn below. So I have a cliff forming an angle of 84 degrees with a lake. So you kind of got to visualize what's happening here. I have this cliff, and it's overhanging over my lake. And it's making an angle of 84 degrees. So there's my 84-degree angle. And it says if I stand at the edge of the cliff, so here I am, standing at the edge of the cliff. Don't jump in the stalls. And I'm dropping a rock. And I would hope that you'd see the right triangle that's formed there. Now, the height of where I'm dropping the rock is 48. And what I'm trying to find out is how far from the cliff the rock will strike the water. So here is my x. And we have to use trigonometry in order to find that value. Before we use the trigonometry, though, we have to define what trig ratio we're going to use here. And here's the thought process of how you do that. You look at where the angle is, you look at where the sides are, and you're asking yourself, what combination of opposite, adjacent, and hypotenuse am I looking at here? And based on that combination, you're selecting what trig ratio you're using. Okay, so step by step. What is the 48 to the 84-degree angle? Opposite, adjacent, or hypotenuse? It's opposite. What is the x? Adjacent. So opposite and adjacent, look back at those definitions if you have to. What trig ratio will we use if we're dealing with opposite and adjacent? The tangent. So we write our equation as tangent 84. You might want to make a note to yourself that what you're taking the trig ratio of, this must always be an angle. Very frequently, one of the mistakes that I see students make is try to take the tangent of a side. You can't do that. The definition, notice, says tangent of angle A, sine of angle A, cosine of angle. You can only take the trig ratio of an angle. Right, so tangent of 84, well, the definition of tangent is opposite over adjacent. So what's on the other side of my equal sign? The 48 over x. Okay, but I'm going to tell you right now, x being in the denominator is kind of an unpleasant place for x to be. I don't like x being in the denominator. It makes it hard for me to do calculations to figure out what x is. So, something that we learned last chapter is, if I put that tangent of 84 over 1, do you see that I now have a proportion? And last chapter, one of the things that we learned we were allowed to do with a proportion is switch things across a diagonal. So let's do that. We're going to switch these two things across the diagonal. And now I'll have x, I don't need to write down the over 1, equals 48 divided by tangent of 84. And before you go typing that into your calculator, if this is the first time you've ever done trigonometry with your calculator, you might not know the order of the keystrokes you need to use. Okay? So, do me a favor and hit the tangent button in your calculator first and foremost, because I'm going to break calculators down into two kinds. There's either the calculator where the word tangent is on your screen, or the word tangent is not on your screen. Okay? So when you hit the button tangent, if you see the word tangent on your screen, clear your calculator, and you're going to type this in exactly the way that it looks. If the word tangent does not show up on your screen, your calculator requires that you type in the angle first and then the trig function. Okay? So I'm going to get an answer on the screen so that you have a basis of comparison, and then we'll troubleshoot. Today. In Friday's notes, we learned how to use trigonometry in order to find segment lengths. Today's lesson is all about using trigonometry to find angle measures. Look at your calculator. If you don't already have your scientific calculator out on your desk, get it out. If you look at your calculator, you should notice that above the sine, cosine, and tangent buttons, there's the shift function for that button, or the second function for that button, and that's the sine -1, cosine -1, tangent -1. Everyone sees that in their calculator. Okay? Those are the inverse trig functions. The inverse trig functions are what we use to find angle measures. Okay? You have that kind of spelled out for you in your notes. I would urge you to highlight it, circle it, whatever you need to do so that you remember that the only time you're hitting shift for these problems is if you're finding an angle measure. You're only using an inverse function to find an angle measure, which is what we're doing in problem 3. The setup of the equation, however, is exactly the same idea as what we were doing on Friday. You look at the angle, you look at the sides, you decide what trig ratio you're going to be using. So in problem 3, I'm asked for angle T. So I look at angle T, I look at the sides that I know, that's 7 and 13, and I decide what trig ratio I'm going to use based on that. So looking at angle T, what is 7? Is it opposite, adjacent, or hypotenuse? It's opposite. How about the 13? What is that? It's the hypotenuse. So I need the ratio that uses opposite and hypotenuse, and that's the sine. So our equation, as I was saying, oh no, it didn't. Look at that. It just disappeared. All right. So much for that. Our equation is sine of t equals 7 divided by 13. Now, since we're using the inverse function to find the angle, what we're basically doing is taking the inverse sine of 7 over 13. And again, those of you whose calculators show the word sine when you hit that button, you're typing it in exactly as you see it on the screen. Do be mindful of the parentheses. Parentheses are important. If you have a calculator like mine, where the word sine does not show up on your screen, then in your calculator you need to do 7 divided by 13 equals, and then shift sine. And let me put the answer on the screen so we all know whether we're getting it right or not. Shift, second. Hold on. Let me get the answer. Okay, hopefully you've started to move on to the next problem. In the next problem, I would hope that you realize that since the 8 is adjacent to the t and 10 is the hypotenuse, this time we'd be using the cosine. Yes, sir. Okay, hypotenuse you should know. The side opposite the right angle. Side opposite the right angle. Okay. The adjacent side is the side that's next to it. And the point of confusion that I often have to deal with is, well, darn it, because the hypotenuse is also adjacent to the angle, but the hypotenuse is like a VIP. Okay, so the hypotenuse is just the hypotenuse. It is not the adjacent side. Okay, and then opposite is the side that it's facing.